All right, this is our review for the Chapter 6 Part 2 test. The test was covering logs, so you will want your exponent table. There will be a portion of the test where there is no calculator and a portion of the test that is calculator. So right now this is the no calculator part. Read the directions, and your goal is to simplify as far as I can. So first, the first two questions are things that are on the mile marker. They're the last two questions, 15 and 16 on the mile marker. We're going to start by expanding this problem. So we talked about, when you expand, you want problem 1 to look like problem 2. So I don't want to see one log, I want to see several logs. So if you just ignore the log for now, and you look at this as 5 times x cubed times y squared, that is where your multiplication is going to turn into addition. And then, just like down here, how everything that is added or subtracted has that log in front of it, that's what's going to happen here. That ln is going to go in front of the 5. It's also going to go in front of the x cubed, but the cubed won't stay here. The cubed is going to move to the front and turn into multiplication. And then the same will happen with the 2 of the y squared. And then this is expanded. So B, the rules don't mention anything about radicals, these check marks. So if you remember that a fourth root is a 1/4 power, this is the same as xy to the 1/4 power. And then that 1/4 actually applies to both of them because it just distributes in. And so this is what we are going to be expanding. So if you look at this as ignoring the log, x to the 1/4 times y to the 1/4 divided by 7, now your multiplication will turn into addition and your division will turn into subtraction. And then I'll bring that log back, and I will put the 1/4 in front of the log plus, whoops, not 2 x's, just 1 x there. And then the 1/4 in front of the y's log, and then minus log 7. And now this one has been condensed. And again, that's just 1/4 log x, not 2 x's there. And then the last one. So the idea, this is kind of hard to notice, but this is x to the 4th over y, and then all of that's cubed. So again, the first thing I'm going to do is just distribute that in, so it's x to the 12th, and distribute it in here, so it's y to the 3rd. And now when you look at this as x to the 12th divided by y to the 3rd, that division is now going to turn into subtraction, and then I'll bring that log base 3 with the x to the 12th, but don't put the 12 here, sorry, put the 12 in front, minus, and then I'm going to put that log 3 with the y, and I'm going to put the 3 in front as well. And now that one has been expanded. All right, problem number 2. So the idea on 2 is when I'm done, I don't want 3 logs or 2 logs, I just want 1 log. So we're going to do the exact opposite. So the first thing is, how we took those numbers and brought them back, those exponents, and we put them as multiplication. I'm actually going to take that multiplication, and bring it back as an exponent. So first I'm just going to move this to 6 squared. Or I'm going to move this 2 into 13 squared, or this x into x cubed. This x here at x to the 18th, and this y as y to the 6th. So just take care of that. And then if you ignore the logs, like we did on the first problem, then 5 plus 7 plus 6 squared will turn into 5 times 7 times 6 squared. And if you just bring the ln back in front of all of that, that's great, but you can easily turn on your calculator. Well, no, I take that back. I'm sorry, you wouldn't have a calculator here. Well, at least it says on this section. So if you did 5 times 7 times 36, because that is what 6 squared is, 5 times 7 times 36, you would actually get this. Now that's a bit to multiply without a calculator. So again, if you just left it like that, that would be fine. Oops, sorry. All right, this one. So ignoring the logs, 13 cubed minus x cubed would turn into 13 cubed divided by x cubed. And they don't write it with the division symbol, they always write it with a fraction. And so now you can just bring the log back. That's great. And you know what? I'm going to go ahead and do, this will be on the calculator portion. So have your calculator out. I'll switch it to that so that it is 13 cubed. Again, that's just 2197 over x to the third. So whether you have log 8 with this or log 8 with this, this is a great answer. This is also a great answer. Okay? And then C. So C is just like B. X to the 18th minus y to the 6th becomes divided. And x to the 18th over y to the 6th. They're going to stay that way. I cannot subtract the exponents. They don't have the same base. Put the log 9 back in front, and you're done. So the common mistakes, people would forget the log. Sometimes they connected an equal sign with these two. There's no equal sign there. All right, problem 3. These are just mile marker questions. This is that middle section. So I give you a log, you give me an exponent. I give you an exponent, you give me a log. In this section, these 4 problems are like the whole test. I mean, you have to know how to do this. So start with your base. 6 to the 3rd power is 216. And 6 to the 3rd power is 216. I don't see a base, so I'd like to put 1. ln always has a base of e, not 10. So e to the y power equals 2x. I don't care what y is. I don't care what x is. That's all you're going to do. Next set of problems. I give you the exponent. You're going to give me the log. So don't forget to write the log. M is little, n is normal sized, equals 3. Over here, same thing. Log e, and then a 5, equals 3y. And if you remember that log e is ln, that's even better, but both answers are fine. So that's the first page of the test. All right, or sorry, test review. So graphing, you will definitely not have your graphing calculator for the graphing portion. So I think for our class, that's definitely going to stand on there. No graphing calculator. So you will have these steps. Every step is worth a point. Make sure you know how to do all the steps. So first, just what are the transformations? So on this graph, my transformations are going to be right 2 and down 5. You're going to find the inverse. When you find the inverse, you're going to leave out every transformation, even if there's a stretch, a compress, and a flip. Okay? So if you leave out everything, we talked about there's this shortcut that your exponent, or I'm sorry, your inverse is just 2 to the x. So there's your shortcut. There's B. Find the inverse. 2 to the x equals, sorry, y. So now I'm going to make a t-chart. So on the content check, some people were confused about what to use for points. Your base is 2, whether you look at the base of 2 here or the base 2 here. And when that is bigger than 1, you use 0, 1, and 2. And the easiest thing to do is 2 to the 0 is 1, 2 to the first is 2, and 2 to the second is 4. The way we did this in the exponent chapter is we would have put a 1 in front of here, and our y-intercept would have been 1. And then how we're growing is 2, so you multiply by 2. 1 times 2 is 2, 2 times 2 is 4. So that's C, and that's the chart for this. So the chart for the logs is the inverse. So these become the y's, and these become the x's. So essentially this is y, and this is x. X and y just switch spots. So that's D. Whoops, and I just realized I made some, okay, no, sorry, E. We're going to graph our new table. So 1, 0, 2, 1, and 4, 2. Now, this is growth. Growth in a log, again, whether you look at that this is growth because it's bigger than 1, or that this is bigger than 1 and it's growth, growth in a log looks like a lowercase r. So just keep that in mind. I still need to now apply my other transformations. So these points are going to go right 2 and down 5. So that's all I'm doing. And the other thing that transforms is my wall. The wall right now is like this, like the letter L, and it's also going to go right too. Okay, and then so that's E and F is over here on the graph. And then G just says state the domain, the range, and the asymptote. So here goes the shape. And to get the domain and the range, I need to put some coordinates with the arrows. So as I go to the right, X is getting bigger. It's not getting stopped by anything, so it's infinity. And as I go to the right, Y is also going up, and it's not getting stopped by anything. So there's my X and Y. When I do the left side, as I go to the left, the X's are getting smaller, but they do get stopped. They get stopped by this wall of 2. And then as I go to the left, they might get stopped by the wall, but the Y's still keep going smaller and smaller and smaller, so I put negative infinity. So let's go for domain and range. Domain are the X's. Put the smaller one first, and then the bigger one, so 2 and infinity. The ranges are the Y's. Put the smaller one first, and then the bigger one. And on the test, you need to make sure that I know which one's the domain and which one's the range. And then my asymptote is this line here. And on this line, every X coordinate is 2. This point's 210, this point's 25, 20, 2, -3. Regardless, X is always 2. Okay, let's go to the next one. So the next one, first thing I'm going to do is state the transformations. This one is only going to be going to the right one. My inverse, sorry, that's step A. My inverse, once I do that, just ignore everything. It's 4 to the X. Now I'm going to make my T-chart. This is growth because this is bigger than 1, or that's bigger than 1. So I'm going to use 0, 1, and 2. So 4 to the 0 is 1, 4 to the first is 4, 4 to the second is 16. Last chapter, we would have put a y-intercept in front, and then our y-intercept is 1. And then what we grow by is 4, so 1 times 4 is 4, 4 times 4 is 16. So D just says switch those around. So these are now the X's, so 1, 4, and 16. These are now the Y's, so 0, 1, and 2. E wants you to graph those, so I'm going to graph 1, 0, 4, 1, and sorry, I just realized I put 6, 16. 16, 2 is not going to fit, but it's still growth. It's still a lowercase r. And now I'm going to take those points, and they're all just going to go right 1. And my wall is also going to go right 1. I can make my lowercase r now. And now I'll do my coordinates for my domain and range. So over here, X is getting bigger. It's not getting stopped. As I go this way, Y is getting bigger. It's not getting stopped. As I go this way, X is getting smaller, but it does get stopped by the wall of 1. And as I go this way, even though X might get stopped, Y is still getting smaller, so I put negative infinity. And now I can put my domain. The domain are the X's, 1 and infinity, smaller than bigger. The range is negative infinity to infinity. Those are your Y's. And then again, my wall, my asymptote, is that wavy line. And on that wavy line, X is always 1. So I just put X equals 1. And that is B. All right, moving on to the next one. So on the next one, I have a little bit more transformations. So first, going through the transformations, this 2 is going to be a stretch. And then I'll go left 2 and down 3. I'm going to leave all those numbers out to go for the inverse, so 3 to the x. Let me just look at something real quick. Yeah, I do have one. Okay, so 3 to the x is the inverse. This is growth because that's bigger than 1, or that's bigger than 1, so you'll still have that lowercase r when we're done. Make my T-chart for this. Growth uses 0, 1, and 2. So 3 to the 0 is 1, 3 to the 1 is 3, 3 to the second is 9. Again, last chapter, our y-intercept would have been 1. We would have grown by 3. So 1 times 3 is 3, 3 times 3 is 9. Now we go for our second, that was step C, second chart for the inverse. So you just switch x and y around. So these are now the x's, because that would become x, and these are now the y's. And now we're going to apply this stretch. We haven't had a stretch or a compress or a flip. Okay, I had to pause the video, so I might be repeating myself. So we switched x and y, and now I'm going to graph, well, I'm not going to graph these yet. Now what I need to do, which I haven't had to do yet, is I'm going to apply the stretch. I'm going to apply this stretch 2 into my table. And so what I'll do is make a new column and make a new y, because all of these y's are just going to get doubled. So times 2, times 2, times 2. And then I don't need these. I'm going to graph 1, 0, 3, 2, 9, 4. So 1, 0, 3, 2, and 9, 4. Again, it's still growth. We already said that. It's going to making this lowercase r. But now I'm going to take these points and do the other transformations. So we're going to go left 2, down 3. So left 2, down 3, left 2, down 3, left 2, down 3. And the other thing that moved was my wall, left 2. And I can make that lowercase r. So it's graphed, and now we're going to go for that domain and range. They've all kind of had the same shape. So on the right, they've all been infinity, infinity. On the left, they're always getting stopped by this wall. This time the wall's at -2, but y is still able to get smaller. So now you can do your domain. The domain is going to be the x's, -2 and infinity. The range, if you haven't figured it out, is always -infinity, infinity on a log. And then my wall, my asymptote, is at x equals -2. And let's take a look at one more graphing, because this type was not on the content check. So again, the first thing we're going to do is identify those transformations. So we got right 2 and down 4. Okay. And you know what? I think let's change the problem, and let's put a negative here. So if you didn't change the problem because you already started it, then just be aware of that. But I want to put a flip in there. So it's also going to flip because of that negative that I just added. Now I'm going to find my inverse. So ignore everything. And this is our inverse, 1/2 to the x power. So this time our g is less than 1. So this is decay. Not because of the negative, but because this is less than 1 and this is less than 1. And decay looks like this. So we're going to make our t-chart, and since it's decay, we're going to use the negative numbers. So this is a good time to actually go back to what we did in the first chapter, and that you realize that there is a y-intercept of 1. Okay, so 1. And that as x grows, we're multiplying by half. So that means half of something gave me this, half of something gave me 1. So half of what gives me 1? Well, that's 2. You're just multiplying by 2 this way. And half of 4 gave me 2. So those are my inverse points. Now I'm going to flip them so that I have the log points. And now I'm going to start to put the transformations in. The first transformation is the stretch or compress, and this time it's a flip. So I'm just going to take the negative, which is like a -1 in front, and just multiply everything by -1. So times -1, times -1, times -1. Whoops. And now I'm not going to graph these. And I'm going to graph 4, 2, 2, 1, 1, 0. So 1, 2, 3, here's 4, 2. Here's 2, 1. And here's 1, 0. And I take this back now when I go back to the shape, because this is decay, but decay is going to flip. So when this flips over, it's actually going to go like that. See here, you can see that mirror image better this way. So that's why our points are curving up. So I've got my flip in there, and now I'm going to apply the other transformations, right 2, down 4. So right 2, down 4, and right 2, down 4. And then the other thing that went right 2 is the wall. And then you can graph your points. And then for your domain and the range, again, if you haven't realized, always on the side it's infinity and infinity. I'm going a little bit into my other area. On the left side, x is going to get stopped by the wall, but the y's will still continue to get smaller. And then you can do your domain. The domain is from 2 to infinity for your x's, and then the range is from negative infinity to infinity for your y's. And then if you get your wall, all the x coordinates are 2 on your wall. And that's it. That's it for graphing. All right, the next part that will not be on the graphing calculator is the next section. The idea is, so what will not be graphing calculator allowed is the graphing, and then this part. I'll let you have the graphing calculator on the rest. So the idea is with your exponent table, you can have that, is you're going to solve for x. So all of these are logs. We're going to make them into e's. So what to the third power is 27? Well, 3 to the third power is 27. I don't see a base. So 10 to the x power gives me 1. So what gets me to 1 is 0. Anything to a 0 power is 1. This one is 2 to the what power gives me 1/8. The negative will give me the fraction, and 3 gives me 8. So together they give me 1/8. And then on the last one, 5 to the what power gives me 125. The answer is 3. So again, use your exponent table. Don't get confused with multiplication as opposed to using exponents. All right, next part, finding the inverse. So we've discussed a really quick way to find the inverse when you ignore everything. Here, we will not be ignoring everything. The inverse of this is a log problem. You'll be making an L. The inverse of this is an exponent. So, sorry, it is an exponent, so the inverse is a log problem. You'll be making an L. Then these two are log problems, so we will be making our E's when we get to these problems. So you can't make your L, you can't make your E until it's just the log or the exponent. So what's not part of the exponent is the 2, but the first thing I'm going to do is you switch x and y around. So f of x is y, so now it's going to become x. I'm going to move the 2 over by adding it, and now I'm ready to make my L. So here goes log, and then 24, and x plus 2, I'm going to put it in parentheses, and then that equals y. And then it's an equation when y equals everything, and since y equals everything, this one's done. So I'm going to go to C next, since it's the same idea. So first I'm just going to switch x and y around. And now I can't do the L until it's just the base and the exponent, so I'm going to add 4 over. And now that it's just the base and the exponent, you can make your L. So it's going to be log with the 6, and then x plus 4, I'm going to put it in parentheses, equals y plus 4. And now it's still not ready because it's not y equals everything, so I'm going to move the 4 over. And this is part of the log, so when I move the 4 over, it will not affect that 4. So I'm going to move the 4 over by subtracting it, so it's log 6 with the x plus 4, and then I just subtract 4. So the idea is if we were graphing it, there would be our inverse, we'd get our points and then transform them left 4 and down 4. Or if this were exponent, then they'd go left 1 and down 4. All right, so the log one, we'll be making the e, but you can't make the e until it's just the log, and the 3 is not part of the log. So I'm going to move the 3 over. Since they're multiplied, I'm going to divide it. Whoops, sorry. I need to switch x and y first. So log 2, and there's the y, and it's just going to be x over 3. And now I'm ready to make my e because it's just the log. So 2 to this power equals y. So 2 to the x over 3 power equals y. And since it's y equals, you're done. So the next one, I'm going to move the y over to the side. I'm going to switch ln to log e, and I'm going to go ahead and just switch x and y around now. So I'm ready to make my e. So e to the x power equals y plus 2. And now it's not an equation until y equals everything, so I'm just going to subtract the 2 over. And now you have your inverse. So big first step, which I almost forgot, switch x and y around and get it so that the single thing is over here. F of x when you start the problem, or y is on the right side. Okay, so now we're solving. Solving logs, solving exponents. The main thing to look for is, does it have a constant or not? If it has a constant, your e will turn into an L, or your L will turn into an E. So first, let's start with this problem. It might help if you actually go through and you add the opposite on this one. And look at this as a -1 with your ln x. It also might help if you realize there's a base of e there. But when I look at this, this is a log problem. I'll be making an e, and I'll be making an e because there's a constant. So I can't do that until it's just the log. So I got to move the 4 and the -1. So first I'm going to subtract the 4. So it gives me -6. And now I'm going to divide by -1. And now I'm going to make my e, but I want a base. So e to the 6th power equals x. So whatever e to the 6th power is, you could actually just leave that as e to the 6th power if you wanted to. But as far as a decimal goes, it's 403.429. And that decimal is from the other side. All right, this is another exponent. This is an exponent problem. I'll be making an L. I'll be making an L because there's a constant. So first, I can't do that until it's just the base and the exponent, so I'm going to subtract the 4. So that gives me 115, and now I'm ready to make my L. So L means right log, 6 then 115 equals this. Some of you can just go to your math button and type that in. A lot of you have to do this. Close your parentheses. So on the calculator, I would do log 115, close the parentheses, divided by log 6. Whoops, I didn't put the division in there. And I get 2.648. But I'm going to leave that long decimal in my calculator. So now to get x by itself, I'm going to subtract 1. So subtracting 1 turns that into 1.468. So I'm just going to do that on my calculator, subtract 1. And then I'm just going to divide by 2. So you get 0.824. Okay, moving right along. So here, if you notice, you don't have a log. Or I'm sorry, you don't have a constant. You have one log here, one log here. They have the same base. We didn't quite have a problem like this because I want to move the 2 over here, but I can't just take that 12 and turn it into a 6. The idea is first, I'm just going to rewrite this as, well, like that. I'm not really writing it, am I? So the idea is I'm going to actually bring this back as a square. And the idea is when you square a square root, they cancel out. So over here, I'm actually just left with x. And now that I have one log here, one log there, no constant, and they have the same base. It's that unseen 10. I can ignore that, and I get my answer. My answer is just 12. Okay? Next one. Here, let's see. We're going to look at this x as a constant. So what we're going to do is go over here, and before I can turn this into an exponent, because it's a log problem, we're going to condense the logs down. So if you ignore the logs and you look at this as 56 minus 7, you're going to turn it into 56 divided by 7, which is just 8. And then you can bring this log 32 back, and now you can solve the problem. So 32 to the what power gives you 8. This is definitely a tougher problem. So this is going back to, you got to think of those exponents. What would be that common base? And a common base between 8 and 32 is 2. So 8 can be turned into 2 to the third, and 32 can be turned into 2 to the fifth with the original x that's there. Now that those bases are the same, you can ignore them, and you get 5x equals 3. So x equals 3/5. So this is definitely a problem that we did not see. So I would not plan on one here like this on the test. So just know that. Good practice though. All right, moving along. So this is an exponent problem that has a constant. So we're going to be turning it into a log, but I can't turn it into a log until it's just this base and this exponent. So I'm going to move the 5 and the 18. And the first thing I'm going to do, I'm going to put a 1 here, is I'm going to add 18. And now to move the 5, I'm going to divide by 5. And that gives me a pretty good number. And now I'm ready to make my L. So again, that big L that you just wrote is your key to write log. But log E is just ln. So I'm just going to go straight to ln of 43.6 equals negative 1x. So anyone can just type in natural log of 43.6. You get this decimal. And now to get x by itself, just divide by negative 1. So your answer is a negative version of that. All right, next one. So on this one, I have a base and an exponent. There is a constant, so I'll be making my L, but I can't make my L until it's just this, so I'm going to divide by 3. So if you take 2352 and you divide it by 3, you get this. So 4 to the what power gives me 784? I don't know. So we're going to turn it into our log. So log 4, 784. And again, some of you can just type that in. The rest we're going to do this. So if you log of 784 and divide it by log of 4, you get this answer for x. X is 4.807. All right, next one. So here I have a constant. So I'll be making this log into an exponent, but I can't do that until it's one log. So we're going to go back to the condensing, those first couple problems, and I'm going to ignore these logs. And I'm going to look as x plus 5 plus x, and I'm going to turn this plus, not this, because this is part of the log, into times. And I'm just going to distribute the x into x and the x into 5. And now I'm going to bring the log back, and then the 2. So now I'm going to make my e. 6 to the second power equals all of that. And 6 to the second power is 36. We are seeing more than one x. You will have a problem like this on the test. There will be one that you factor. So I'm going to bring the 36 over. If you don't want to factor, you can always do the quadratic formula. A is 1, B is 5, C is negative 36. But otherwise, if you multiply, you're going to get negative 36x squared here. Whoops. And 5x here. And then your factors are going to be 9 and 4, with the 4 being negative. So now I'm going to rewrite it, but instead of 5x, I want this 5x. So again, it's just x squared. There's 5x. There's minus 36. You're going to group them, or top row of your box and bottom row of your box. And out of this, I can factor out an x. And then x times what is x squared? That's the x. And x times what gives you the 9x? That's 9. So that means this has to be x plus 9. And that means what in front here times x gives you the negative 4x. That's negative 4. And really squishing this in there. So now my two parentheses are x plus 9 and x minus 4. And my two answers are what makes these 0. So negative 9 and 4. Alright, next problem. So on this one, I see logs. I don't see a constant. I don't need to make an e. And there's just one log here and one log here. The only problem is this 1/4 is not a constant. So I'm not going to, be doing the e. I'm just going to move this back as an exponent. And again, we didn't see a problem like this on our review, or I'm sorry, on our stuff. So 81 to the 1/4 power, that's like the 4th root of 81. And the 4th root of 81 is just 3. So now if you just ignore the logs, you're going to see that x is 3. Alright, almost done with solving. So again, I am looking at this problem. And I'll be honest, I'm not quite sure. This review was borrowed from somebody else. These, I can't have x and y. So, what we're going to do is, let's change, there should be numbers here. So let's just change the numbers, the y's. So, sorry about that. I didn't realize that. So let's change this y into a, let me think of a number. Let's turn this into a 26. Okay, so there is a log, and there's a constant here and here, and that means I'm going to be making my e, but I'm not going to make my e until the 3 and the 5 are over. So first I'm going to subtract the 5, and I'm going to switch it to being over here. So subtract the 5, that's 21. I'm going to move 3 by dividing it. So that gives me 7. And now I'm ready to do my e. Let's put our base. So e to the 7th power equals all of that. And then you can go to your calculator, figure out what e to the 7th power is. It's this. And now to get x by itself, just add 1. So your answer is 1097, and then your decimal. And let's go ahead and do the same for the next one. Let's just turn this y. Let's turn it into a, let's turn it into a 10. Okay, so there is a constant here and here. We're going to get just the base, which is ln x, and we're going to move the negative, which is like a negative 1 there, and the 25. So first I'm going to subtract 25. I'm going to put it on this side now, and that turns that into negative 15. I'm going to divide by negative 1. And now I'm going to make my, my e. So there's the base. So e to the 15th power equals x. So whatever e to the 15th power is, that's x. And I'm not going to type that one because I just think that's going to be a slightly bigger number than we're used to, but e to the 15th power. Okay? Okay, so we worked on a few word problems on that pink page. 3 or 4 on the front, 3 or 4 on the back. So here are just some more, and I would definitely take a look at these. So you have these formulas. You will get the formulas again, but the idea that it says compounded quarterly means we're going to be using that really, really big one. So here it is. Okay, and we're going to start putting the numbers in. So 20,000's invested at this amount compounded quarterly, and we're going to use logs to figure out how many years until the fund is 32,000. So 32,000 will be the y. P is the initial amount, that's 20,000. You're going to have your 1 plus your rate. Your rate is 3.4% as a decimal, that's 0.034. Compounded quarterly, that's the n, that's 4. And then n, the 4 is going to appear again with t. So our job is to solve for t. So what we're going to do first is just go into the parentheses and get this to be a nice number. So I'm going to take 0.034 and divide it by 4. Okay, just getting that fraction to one number. And then I'm going to add 1 to it. So that's what the parentheses is worth. So I'm going to rewrite it. All right, so if you look at this, this is what we just did. We have a constant, we have an exponent problem, we're going to be turning it into a log, but I can't turn it into a log until it's just the base and the exponent. So I'm going to divide this 20,000 over to the other side. So if you take 32,000 and divide it by 20,000, you get 1.6. And then I have this. And it would be easier if this 1.6 was on the other side for our L, but we're ready to make our L because it's just a base and an exponent. So, okay, so log, and then this decimal number with 1.6 behind it equals 4t. Again, some of you can just type this in. The rest of us are going to have to do this. Log 1.6 over log with that longer decimal number. So I'm doing that right now. Again, don't forget to close those parentheses. So when I do that, that's equaling. So I made a mistake over here. I put 46. I should put 4t. So when I'm done, all of this is going to be right up here now. Move over a little bit. It's going to be 55.529 equaling the 4t. And now to get t by itself, I'm just going to divide by 4. And 13.882. It says round to the nearest hundredths, but we've been going 3 decimals, so I just went 3. All right, next one. So Thursday night, you're rushed to the ER with a bacterial stomach infection. The nurse gives you antibiotics and says you will feel better in a day or 2. The amount of bacteria present in your stomach after T hours is modeled by this equation. So B is the amount of bacteria. So how many bacteria will be present in your stomach after 3 hours? We'll just put the 3 in here. And then you can actually just go to your calculator and type in 40,000 e to the negative, and then just take this times 3. So on your calculator, that would look like 40,000. Yeah, that's enough zeros. Do the second ln button, and then it just builds an exponent for everyone. You can put negative 0.2386 times 4. And that's how much bacteria is left after 3 hours. It should be going down. So you get 15,401.724 bacteria. So when will you only have 1 left in your stomach? Well, that means I need to put a 1 here. Actually, I'm going to put it on the other side. So this problem has a constant. It's an exponent. I'll be making it into a log. I can't make it into a log until it's just the base and the exponent. So I'm going to divide, don't subtract that 40,000. So what I need for you guys to see is the number that you're going to get. Just write that down. So that means we have e to this number equals this. What that means is on this 2.5 is that decimal is just going 5 times to the left. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so we've got 0 sitting in here. So this is 0.000025. But I'm just going to leave this on there. So now I'm ready to make my L. So log E, which is just ln, of this, weird number. That's not E. That's the way it is. Equals this decimal number. So now I can just everyone just type in ln. So I don't want to retype this number in, but it's stored as the most recent answer. So I'm just going to do ln, do that second negative key, so it takes this and put it in here. Okay? So that's all I'm doing here. Anyone can do that on their calculator. I get this, negative 10.597. Whoops. Equals this decimal. And now to get t by itself, I'm just going to take this number and divide it by this number. So it's already on there, and I'll do divided by negative 0.2386. And there is your t. That's how long it's going to take. So t is about 44, I think this is days, so 44.411 days, over a month. Okay? All right, and, well, I got to pause here for a moment. Well, no, I think I can get this last problem done. We're going to get it done. I have a meeting to go to. Okay, so the next Beaver puts up a YouTube channel. Initially, his 6 best friends are all subscribers. After he puts up his first heart-throbbing tune, his subscribers increase every day by 34%. That's the rate, 34%, which, remember, you will want to use as 0.34. So nowhere in this problem was the word compound used, so we're going to use this basic one, y equals b times g to the x, and g comes from 1 plus or minus r. So b is the initial amount, so his best friends, that's b. So y equals, well, it might not be y, yeah. Y equals 6, and then g. The rate is 34%, 0.34, and it's increasing, so we're going to do 1 plus 0.34. So 1.34 and then my x power. That's your equation you're going to use. So how many days later does he have this many subscribers? Well, that's y, so that's going to go in here, but I'm going to move it to the other side. So this is an exponent problem. I'll be making it into a log, but I can't until it's the base and the exponent, so we're going to move the 6 over. I'm just going to divide this by 6. And that gives me 1900. I'm ready to make my L. That wasn't a very good L. So log, putting it over here, of 1.34 and then 1900 is going to equal x. So again, some of you can go to your calculator, type that in. The rest we're going to do this. Close your parentheses. So just log of this number and log of the little number, looking like this. And so when you're done, 25.795. So x, I'm going to write it over here. Days. And that is the review.